So we isolated some solid from the recrystallization in 50% ethanol of the brominated acetanilide, and I let the rest of it evaporate in the beaker, and you can see there's a ton of solid in there. So we really got very poor recovery, and we'd like some more of that solid. So this I left it in that beaker labeled DCL-10-49A. So I'm going to try to recrystallize that and get more compound out. And that was recrystallized from 50% aqueous ethanol. And it was pretty soluble. So my theory is that the reason we got a poor recovery is it's quite soluble in ethanol. And maybe if we use as a recrystallization solvent something that's got a larger percentage of water and a smaller percentage of ethanol, it'll be less soluble in that, and we can get a better recovery. So what I'm going to do is I'm going to make up an ethanol water solution but this time I'm going to make that ethanol water solution 75% water and only 25% ethanol. So I'm going to measure out 10 milliliters of ethanol. And 30 milliliters of water. I'm going to pour those both into a clean 100 milliliter beaker. And put a stir bar in there, line around there. So we'll heat that up on a stirring hot plate. Turn that on, spin it at about 450 and maybe 300. We don't need it to stir vigorously. And we're going to crank that up to about 150 on the hot dial. That'll get that boiling fairly quickly. And while I'm waiting for that, I'm going to grab a 25 milliliter filter flask with the usual number 2 filter adapter and Hirsch funnel. My tweezers are out already. Grab a piece of filter paper. Got some glassware drying from another experiment here. One piece. These two are stuck together. There we go. And we can clamp that in there and Attach our vacuum hose. That'll be ready to go when we need it. Make sure that's actually covering all the holes. It's barely big enough to cover the holes. Have to get it situated just right. And then we'll just take a little bit of this 75% aqueous ethanol and 25% ethanol, 75% water. Just wet that down so it's sealed tightly. There are boiling stones in there already, but boiling stones clog, so you can't really use them again. I will need to add some fresh unclogged boiling stones to that. So I'll add 2 more good sized stones. So we're going to get that boiling, and then we're going to add a little bit to this and try to get that to go into solution. See if we can't get a little better recovery, because we didn't really get very much of the recrystallized 49B, which is sitting in the desiccator. You can pull that out and have a look at it. Find the right one. It's 48A. Maybe it's in a different desiccator. Second. That's tranexamic acid from last semester. Lots of white solids. There's the 49B. Hopefully not as sticky as it was. So we can pull that piece of filter paper out and scrape the solid off and get a mass. But we can tell the percent recovery is going to be poor based on how much solid there is in that other beaker. So let's get a mass on this 49B, which was the first attempted recrystallization. And we can calculate a percent recovery. And that looks like 8.226 grams for that first batch. That's enough material to obtain data on, but it's really not a satisfactory yield. You will notice that it was very wet before, and now it's quite powdery, having dried in the desiccator for over a week actually. So I got involved in some other experiments. So that's nice quality solid. I just didn't very much of it. So we'll put that back. And we're going to see if we can't get a better yield by recrystallizing additional material. Smack the camera into the hood vent. So it's getting fairly warm. I'm going to take one pipette squirt, which is about a milliliter, and start kind of scooching that solid off the walls of the beaker. Try to get a uniform mix. I'm going to want to cool this in a much smaller vessel so I don't lose tons of solid on the walls of the vessel. And if history is our guide, it's not going to take a lot of solution. So I think the optimum vessel for recrystallizing that is going to be one of these 10 milliliter flasks. Remember, we did it in a 4-inch test tube, or 3-inch test tube last time, rather. And the problem with that was it became such a rock. We had such a saturated solution that when it crystallized out, it was difficult to get it out of the test tube, and we had to use a lot of ethanol to wash it out, and lost compound as a result. So I'm going to heat that as well. And I'm going to need a nice bath, so I will go and fetch some ice. We'll need the ice bath both to cool our crystals and to cool the ethanol that we're going to use for our wash. I think I didn't actually use this guy. But this pipette bulb is crap. You can see that it sticks to itself. So something has obviously been put in there that's contaminated it, rendering it quite useless. And get rid of it and replace it with a decent bulb. So I want to get this pretty much boiling. See if I can get all of that to dissolve. I think I will add another milliliter and wash it down the walls, try to get that last solid off the walls. I'm going to add a little bit more solid than I think it's, or a little bit more solution than I think it will take to evaporate all of it, or to dissolve all of it rather, in the hopes that it won't form quite as solid a mass once it crystallizes. So we'll let that boil. Solid in the neck here. Probably not going to take a lot more ethanol. Tilt that to get the solid that's on the walls of the beaker dissolved. Large surface area on a beaker is why it's not usually the best choice for recrystallization. But the more transfers, the more you lose compound as well, so I didn't want to scrape that solid into anything else and leave a bunch behind. So I'm going to add one more pipette of the ethanol and wash the walls of the beaker down. And now I'm going to pull those boiling stones out, because I can pull them out easily while everything's fully dissolved. You can see that there's a little solid coming. And then what I want to do is pour that quickly into the Erlenmeyer flask. And it will cool and may start crystallizing almost immediately. I want to cool that slowly, so I'm going to stick a beaker upside down. It's about 5 milliliter total volume, it looks like, based on reading the volume there. So we'll let that cool, and we can set that aside.